All right, good morning. Happy Thursday. Give a couple of announcements. Hope you're doing well. All right, today I'm going to be teaching lesson 17.3, and I'm sorry for the scare of having an exam tomorrow because I forgot that I've been teaching 2 lessons lately and having a test, but I do want to have an exam on 17.1 through 17.3, and it's kind of hard to have the exam if I haven't taught 17.3, so sorry about that. Also with the AP testing going on, I know a lot of you are studying for AP tests, and I really don't want to interfere with that. So if you want to mark your calendar, I want to have this exam 17.1 through 17.3 on Monday, May 25th. So we're going to be waiting to take it, which always scares me, but I can't think of a better time to take it without interfering with your AP testing. So in addition to that, I'm going to try to get into chapter 18 because you really need to have it. And so there's a possibility of taking 2 tests real close together. So for sure, 17.1 through 17.3 will be on Monday, May 25th at 2:30 in the afternoon. And I'm going to continue teaching. So lesson 18.1 will be coming up soon after that, and I want to take an exam soon after that test on May 25th. I think that's it. All right, so today we're going to talk about using a Pythagorean identity. And when I say Pythagorean, the first thing that should come to mind is the Pythagorean Theorem. And so the Pythagorean theorem, of course, is a squared plus b squared equals c squared, and it applies to a right triangle. So this is something that you've had for a while now, is the Pythagorean theorem. So we're going to be looking at using a Pythagorean identity. So I do recommend that you do the Explorer. I am going to go over, am I going over the Explorer? I am not. So you need to do the Explorer. I'm going to start with objective 1 here. All right. So this is lesson 17.3, using a Pythagorean identity. I'll write it up here. California Common Core Standard F-IF.8. Okay, so here we go. So you're going to find the value. I'll get another pen. All right. So we're finding the value of other trig functions given the value of sine of theta, which is the y value, or cosine of theta, which is the x value in the ordered pair. All right. So can you guys see the boards okay? I don't see anybody, so I can't tell what's going on. All right, so what does the Pythagorean theorem look like with sines and cosines? So there you go. This is the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So you can think of this as y squared plus x squared equals 1. The square, sometimes you'll see it written on the outside, but most of the time you see the square written like that. And so this comes in a bunch of different flavors. So you don't need to know this right now, but I'm just going to show you in trigonometry. If you solve for, pre-calc, if you solve for sine squared, you can write another formula. So if you subtract cosine squared, you get 1 minus cosine squared theta. And students use this a lot in trigonometry in the proofs that we do. So there's one section in chapter 5 where every section has it has proving in it, and they call it verifying. And students are constantly using this fact. So they don't memorize it because since they know this fact, you can derive this formula from that by subtracting cosine squared from both sides. In the same vein, if you subtract sine squared from both sides, you can write yet another formula, which would be 1 minus sine squared theta. And they use that just as often. So basically from this one Pythagorean identity, two other formulas come from it. And so like I said, they just memorize this one and they're able to derive the other ones quickly. Now you're not using those today. What you're going to be doing is you're going to be taking, my pen's running out. You're going to write yet another formula. So you're going to take that formula, which is down here, and you're going to solve for sine. So what you're going to do is just like we did in algebra, you're going to take the square root of both sides. Don't forget plus or minus. So sine times sine is sine squared. So since you have 2 under there, the square root of a square is sine. And you get this, 1 minus cosine squared theta. So there, you just came up with another formula. Same thing with cosine. So you have cosine squared theta equals 1 minus sine squared theta. That's what they're using in pre-calc. If you want to come up with cosine for these problems we're going to do right today, take the square root of both sides. Don't forget plus or minus. So on the left, you get cosine of theta, and on the right, you get plus or minus 1 minus sine squared theta. So you're going to be using this one and this one. Okay. So let's look at how we're going to use these. So here's your first problem. Find the approximate value. And as soon as I say approximate, they're talking about using a calculator. So whenever they say find the exact value, don't use a calculator. I did notice some of you with that unit circle quiz, that you're using a calculator. You do not use a calculator on the common angles. Even the ones around the unit circle, you do not use a calculator. You must do those by hand. All right, so find the approximate value of each trigonometric, I'm just going to write trig function. So they want a value, and here's the first problem. Given that sine of theta, so remember theta is the angle, so sine of theta is 0.766, and they're going to say where theta, okay, so that's the angle. So they're saying that the angle must be less than pi over 2, or 90 degrees, and it has to be greater than 0 radians. So for sure, be careful of your calculator, because it needs to be in a radian mode, and this is what tips you off. So sometimes students will say, well, you know, how do I know what the mode is in my calculator? Well, if you didn't have this, you wouldn't know. But since they gave you, this is a restriction. So they're saying that this angle theta has to be between 0 and 2 pi. Because you do realize that sine is positive in 2 different quadrants. So not only sine is positive in quadrant 1, but sine is also positive in quadrant 2. I'm laughing at my kitty right now. He's listening to the lesson like he's learning something. Storm, are you learning something? Okay. All right. He's paying close attention, just like you guys are. It's distracting me. Anyhow, sine is positive in 2 different quadrants. And so, yeah, they're restricting it to the first quadrant. So they give this fact, they give this restriction, and then they're telling us what to do. Find cosine of theta. So they want to know the value of the cosine of theta. Okay, so let's take a look at what we're going to use. We want to find cosine, so we're going to use one of those. And the question is, are we using the plus or the minus? And since they want positive, we're using the positive one. Actually, let's not do that. Let's wait, because that's not necessarily true, because cosine's positive in 2 different quadrants also. So hold that thought. So we have cosine of theta is equal to plus or minus the square root of 1 minus sine squared theta. Make sure you run that radical all the way out. All right, so cosine of theta, and we're still going to write plus or minus here. We don't have to. Okay, so what we're going to look at is this fact right here. Since the angle is between 0 and pi over 2, that means we're in quadrant 1. So, like I said, it's positive. Do it right away. No need to wait. The reason why in my notes I waited was because normally I have you look at the quadrant at the end. So if you want to wait to look at the quadrant at the end, that's fine. Just trying to be consistent. All right, so now we put in the value. So this says 1 minus, there's sine of theta is 0.766. So don't forget that we have to square it. Now that negative is part of the form. So we have to square that. There. All right, so this is positive, and now we put this in. So this would be 1 minus that. You can put it in the calculator all at once if you want. Just be careful with whatever you do. So you can either wait and evaluate the radical. We just don't want to round too much. So, or you can put this in the calculator. So let's try this and see if you can do it. Put in the square root of 1 minus parenthesis, dot 0.766 quantity squared, and tell me what you get. Somebody. All right, let's not do that. Leave the radical, don't use the radical yet. Just put in your calculator 1 minus quantity 0.766 squared and tell me what you get. Somebody, you need to unmute yourself and tell me what you get. 1 minus that. We'll do the radical in a minute. I don't have this in my notes, so I need to know what this value is. 1 minus 0.766 quantity squared.
0.4132.
Don't round too much. Give me some numbers. Round too much. 0.413.
244.
Okay, thank you. Okay, now go ahead and put that in the calculator. So take the square root of that and tell me what you get.
.64284.
Okay, so if they want you to round to, depending on how they want you to round, if they want you to round to the nearest hundredth, which will probably be what they'll have you do, it would be 0.643. Pretty simple stuff. I'm gonna erase this. You guys have this written down, so you have the formulas. So I don't care if you skip a step, but just make sure you're using the calculator right and make sure you have your calculator in the correct mode. Let's try another one. So this quadrant one was based on this fact. It has to be less than pi/2 radians and greater than 0 radians. The next problem. So once again, they want us to find the approximate value of the trig function given that this time they're saying cosine of theta is negative 0.906, where okay, now they're saying that theta is less than 3 pi/2 radians and greater than pi. So from that, you have to figure out where they're talking about. Where's the angle? They're saying the angle is less than 3 pi/2 and greater than pi. So you have to know what quadrant that is in. And so then after that, they're saying find sine of theta. All right, so they want us to find sine of theta this time. So we have sine of theta is equal to plus or minus square root of 1 minus cosine squared theta. And so sine of theta, we can figure out the quadrant now or later, doesn't matter. But that right there, where theta is less than 3 pi/2 and greater than pi, that puts you in quadrant, what, 3? Yeah. All right. So in quadrant 3, over here in quadrant 1, the signs were positive, positive. Over here in quadrant 3, the signs are negative, negative. So we have to decide, are we using plus or minus? In this case, sine is negative in the third quadrant. And now we just put it in. So this would be 1 minus negative 0.906 quantity squared. So you have two negatives. One is in the definition and one is in the problem. And so like I said, I don't care how you put this in the calculator. It's got to be careful. So let's leave that for later. How about just put that in? One plus, well, you can't, okay, hold on. That's not a plus yet, right? Pay attention. A negative quantity squared is a positive. This negative doesn't go away. So this really means 1 minus 0.906 quantity squared, because the negative has to be squared. Be careful. Lots of negatives. All right, so go ahead and put that in the calculator. 1 minus a negative quantity squared, or 1 minus, if you get rid of the negative right away so you're not confused, I don't care. What do you get? And I don't have this step of my paper, so you're going to have to tell me. What's 1 minus that thing squared?
Point 179,164.
Don't round too much. Thank you. All right. And then take the square root of that thing and tell me what you get.
.423.
Yeah. 0.423. Thank you. So in other words, what this is saying is that the y value of the angle, the point, that's associated to the y value is negative 0.423. So that's the y value of the angle. I should say the y value of the point associated with the angle, right? Because you have an angle, but then you have a point that's associated to it. Okay. So let's do another one. This one's a little different. Okay, this one, they're saying, given that cosine is negative 0.994, where the angle is less than pi and greater than pi over 2, find sine of theta first, then find tangent of theta. Okay, so this little restriction here, where it's saying theta is less than pi and greater than pi over 2 radians, your calculator is still in radian mode. This little thing right here is saying that you're in quadrant 2, where the signs are negative, positive. Keep that in mind. All right, so they want us to find sine of theta, and you probably already have this memorized by now. It's plus or minus a radical, 1 minus cosine squared theta. And we can do this now if you want. Sine is positive in the second quadrant, so this is positive. And we have 1 minus a negative 0.994 quantity squared. Too bad it's not that one. It looks almost exactly the same. So this is going to be 1 minus, and this, a negative quantity squared is positive, and we have to square 0.994. So can you give me that number, please?
0.056.
Okay, is that,
That's 1 minus negative 0.994 squared.
okay, yeah, what was that number again?
0.056.
Is that what you had there? Is that what you said?
No, that's the already subtracted.
1 minus, okay, sorry. You got to tell me again because my mind is.
So 1 minus 0.994 is going to be 0.056.
I don't know if you rounded too much because you should take, since we're not done with the problem, this is too much rounding. So it might throw our answer off. So you want to round it. You want to take it out like six or 7 places. So we'll see.
That's wrong. That's wrong. I'm sorry.
That's okay. Let's try it again. No problem. All right. So what we want to do is how about put this in the calculator? 1 minus 0.994 quantity squared. So let's leave the radical. And let's just do this on the calculator. What's 1 minus that quantity squared?
0.011964.
Thank you. All right. And so now let's see what we get. That's better, by the way. Okay, so now do the square root of that thing and tell me what you get. Somebody, square root of that.
0.10938.
That's right. This is right. So we didn't, yeah, it was, I think the 3 was next. So that is right. Okay, but we're not done because they want us to find tangent. And I'm going to give you another identity. What I'm going to give you right now is used extensively in pre-cal. So I'm going to kind of stop the problem right now for a second and put these up, and then I'm probably going to have to erase some. You have to have them on your sheet of paper. This is used extensively. It's tangent of theta. Now, you've seen this defined a bunch of different ways. You've seen this defined as y over x, right? You've seen it defined as opposite over adjacent. Well, here's yet another definition. Sine of theta over cosine of theta. So now you have another one to add to your repertoire. So you have tangent of theta being y over x, you have tangent of theta being opposite over adjacent, and now you have tangent of theta equaling that. And this is useful for this problem, right? Because they want us to find tangent. So we know sine of theta, we know cosine of theta, so we're good to go. I'll give you those other definitions in a minute. I'll continue the problem. Okay, so tangent of theta. Approximate. Sine is 0.109. And cosine of theta is negative 0.994. So we can figure out tangent. So go ahead and tell me, what is that? Negative what?
Negative 0.1096579.
Yeah, 109, so it's about negative 1.10. Kind of being consistent. This started out as 3 decimal places to the right. We wrote this as 3 decimal places to the right. I'm writing that as 3 decimal places to the right. All right. So hopefully you're following this. Well, it's not that hard, really. You do always have to be cognizant of what quadrant you're in. So now positive and negatives matter more than they've ever mattered before. You can't mess up. If you mess up, it means you don't know what quadrant you're in. So it's super critical now. You basically don't understand the trigonometry if you're messing up on positive and negatives. So I just want to talk about this definition for a minute. So like the Pythagorean identity, this can be written a lot of different ways too. So if you solve for sine by multiplying both sides by cosine, you can get, if you wanted, cosine of theta, tangent of theta. So I don't know when or why you'd want to use that, but you could do that if you wanted. Like, for example, in a proof or something, if you wanted to take this thing out and put sine in its place, these are equivalent. You could also solve for cosine. So if you multiply both sides by cosine, let me just do this real quick. You get this. If you want to get cosine by itself, you would divide by tangent. So if for some reason you had this thing in a problem and you wanted to take it out and put that in. So what I'm basically saying is that throughout pre-cal, you're going to be given formulas that you can rewrite. And you don't memorize all these, you just memorize the main one and you derive the other formulas from that. So kind of like the unit circle. I didn't have you memorize the whole unit circle. I just had you memorize the first quadrant. Because you can get the other information from just looking at the reference angles and their corresponding angles in the other quadrants. You don't need to memorize the whole unit circle. All right, let's try another problem. So this one's going to require some work, but it's not hard. It's just requiring some work. All right. So here we go with the word approximate, which means you're using a calculator. Okay, find the approximate value of each trig function. Okay, so now look what they're giving you. They're giving you tangent of theta being about negative 2.327, where the angle is less than pi and greater than pi over 2. So what does that mean? That means the angle is in quadrant 2, where quadrant 2 is negative positive, so keep that in mind. They want you to find sine and cosine. So see, now they're not giving you sine to find cosine and giving you cosine to find sine. They're giving you tangent, and they want you to find sine of theta and cosine of theta. Great. That's a little bit harder. So what are we going to do? Well, we do have a formula now with tangent in it. And you just saw me write it. It was sine of theta equals cosine of theta times tangent of theta. Watch what I'm going to do here. What I'm going to do is I'm going to put in the value for tangent. It's going to be approximation, by the way, because I already approximated. We don't know what cosine is. And tangent, they're saying, is negative 2.327 approximately. Right? So now I'm going to put this on the back burner. I'm just going to let it sit there for a minute. So don't forget I did that. So I'm going to stop that for a second. And now what I'm going to do is I'm going to use the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Now, you do this all the time in pre-calculus. Watch what I'm going to do. These are unlike terms. So this is like an x squared and a y squared. It's actually y squared and x squared. They don't go together, right? So this is like trying to solve a quadratic that looks like this. X squared plus y squared equals 1. Can't solve it. Two different variables. So what do we do then? Well, what we can do is we can take this sign out and put this in, because aren't these equivalent? So I'm going to take this out and I'm going to put cosine of theta. I'm going to put that in front. Negative 2.327 times cosine of theta plus cosine squared of theta equals 1. Okay, so let me explain what I did. This is squared, by the way. So because I can't do anything with what I have, what I did was I took out this sine squared and I put this in and squared it. I put that in front. So I took negative 2.327 and I squared it. So I substituted. I took that out and I put this in, and this is what's left over. And now what I have is I have a problem with all cosines, which means what? That I can solve it. So remember, they want me to find cosine and sine. Well, how do I find them if I don't get this like terms? I have to have like terms. Over here. So now, by substituting, by solving sine in terms of cosine, I can substitute in and find cosine. Okay, so I need your help right now. What I need you to do is I need you to put negative 2.37. Remember how you have to square everything? So if we did this, we have to square x squared, y squared. So a negative squared is positive. I need you to put in your calculator 2.327 and square it. So what's 2.327 squared?
5.414929.
So it's about 5.415. How's that? Is that okay? Okay. And cosine would be squared now. Plus cosine squared theta equals 1. So what I did is I squared everything in the square. This negative squared, 2.327 is squared, cosine squared, and now I can add those. So aren't these like terms now? Isn't this 5.4 whatever plus 1? So doesn't this turn out to be 6.415 cosine squared theta? Because I'm adding like terms, right? And now can't we isolate the square? So we're going to divide by 6.415 to both sides, because we're isolating the square. These are all approximations, by the way. So what's 1 divided by 6.415?
0.15588.
15588.
88.
I'm just going to say 9. Okay, I'm being really careful about the way I'm rounding. Now we take the square root of both sides. So we have cosine of theta is about, and you have to put plus or minus, right? Because don't we, remember what I said over here? That we have to pay attention to what quadrant we're in? A spider that almost crawled on my foot. All right. So back over here. Don't forget your plus and minus. So what's the square root of 0.1, square root of 1.1559? Plus or minus what?
0.3948.
About 0.395. And here's the most important part. Is it going to be positive or negative in quadrant 2? Is cosine positive or negative? It's negative, right? So this is the one thing that students mess up on, is the signs. But you have to stay cognizant of what quadrant you're in. Now, in a minute, when we find sine, sine's going to be positive in the second quadrant. All right, I'm going to take questions in a second, but we're not done. You still have to find sine. All right, so sine of theta, just right over here. Sine of theta was solved up here, remember? And we said that sine of theta was about cosine of theta times negative 2.327. Well, can't we put cosine in now? So isn't this going to be about negative 0.395 times negative 2.327? Yes. So I'm putting it back into here. So what is sine then? Go ahead, I'm listening. A negative times a negative is a positive. So it's going to be positive what? Go ahead, I'm listening. Somebody. Hello.
9.1916.
I don't know. I don't think that's right. It should be 0.9. This is 0.395 times 2 point. What'd you get?
.919.
All right, now, if you have a question about how to do this problem, make sure you ask me. What we did right here is we solved for sine in terms of cosine. And the reason why we did that is so we could take this sine squared out and put that in its place. Make sure you know your rules. When you square a quantity, you square everything in the quantity. And after I squared everything, I had like terms. Don't forget to line up the decimals. So 5 point plus 1 is 6. Then what you do is you use square root method. So you isolate the square. Don't forget plus or minus. How do you determine the plus or not minus? You remember what quadrant the angle's in, and the angle was in quadrant 2, where cosine is negative and sine is positive. So cosine ended up being negative, sine, see how it turned out automatic? See how the math worked? It automatically turned out to be positive. Because it should be, right? Math all works together, so it turned out to be positive, which is right. Okay, do you guys want to, I'm going to work one more problem similar to this. Do you want to ask me any questions about this? Okay, please ask me now, because I'd rather answer it in front of 40 people instead of answering, 40 people 40 different times. So if you have a question, ask me about it now while it's up here.
I'm just kind of confused on why you plugged in negative 2.327.
Okay, so what I did is, you see how it's given right here? Tangent. So the reason I plugged it in, so I would only be dealing with sines and cosines. And specifically, I plugged it in so I could get sine in terms of cosine only. I didn't want tangent involved in it. So because they gave me this fact, I plugged the fact in. So in other words, I took tangent out and I put the fact in. The tangent of theta is about negative 2.327. So basically, it allowed me to get rid of tangent. So I put the actual value in. So basically, I was trying to put everything, that's what you're trying to do, is think about it. In algebra, when we're solving for a variable, we want to solve for x, right? We don't want two unknowns. So this is the important step right here, is that, see how I got everything in terms of cosine? That means I can find cosine. If I get everything in terms of sine, I can find sine. If I get everything in terms of x, I can find x. So that's what's happening here, is I'm trying to get the problem in terms of one thing, or in this case, one trig function, so I can find that trig function value. Okay, anybody want to ask me a question? I'm going to do one more problem. I'll try one more. Same type of problem. Okay, so let's see what they give us here. So we have tangent of theta again. So they're giving us theta, and they're saying it's about negative 4.366. And they're telling us where the angle is. That's important because you have angles. You could have two different answers for this, for the same angle. Let's see here. It's less than 2 pi. And greater than 3 pi over 2 radians. So where is that? That's saying that the angle is in quadrant 4, isn't it? And isn't quadrant 4 positive, negative? Which means cosine is positive and sine is negative. That means when I do this problem, if they ask for sine and cosine, cosine better be positive, sine better be negative. So look what they're saying again. They're saying given tangent, once again, they want us to find sine of theta, which is going to be negative, and cosine of theta, which is going to be positive. Now the question is, what do we do? Well, we're going to take the same approach. We're going to say sine of theta can be derived from our Pythagorean identity. Tangent of theta is equal to sine of theta over cosine. We can rewrite it to this, which is really weird, but whatever. So what I did before and what Max was asking me about is what did I do? Why did I do that with tangent? I'm going to do the same thing. I'm going to multiply by the actual value. Okay, now I have sine in terms of cosine. So I'm going to write out my Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So you see what I'm going to do? I'm going to take this out and put this in its place so that I have all cosines. So I'm going to put this in front. So it's going to be negative 4.366 cosine of theta. And I'm going to square it because this is sine and cosine, but this is sine squared, which means I have to square that. And the rest of this is plus cosine squared theta equals 1. So I took that sign out and I put that in its place and I squared it because that's squared. Okay, so now the negative squared is positive. What's 4.366 squared? I need help. What's 4.366 squared?
$19.0619.
Yep. Okay, hold on. Let me just erase this and you can tell me again. That's right. Go ahead again, 19.
19.0619.
Okay.
You want the whole number?
What was after the 9 though?
56.
5?
Yeah. You can round it to 0.061956.
Yeah, how about we just, since this is 3 decimals, how about if I just round it to 2? All right. Cosine squared of theta plus cosine theta equals 1. Okay, so we had to square that. We got cosine squared and then that cosine squared. So now when we add them, this is 19 plus 1. So it's going to be 20.062 cosine squared theta. So I'm just adding like terms. Right? 19 plus 1, that's cosine squared. Cosine squared, those are like terms, like x squared plus x squared is 2x squared. So now, square root method. Divide both sides by 20.062, 20.062. Cancel, isolate the square. These are all approximations, by the way. All approximations. All right, so what's 1 divided by that thing? Adam sing. Hello. 1 divided by that.
0.04984.
It's about 0.050. And now we isolated the square, take the square root of both sides. Don't forget plus or minus. So we found cosine. Well, not yet. What's the square root of 0.050? Go ahead, Mustang. Hello? This is taking so long. Square root of 0.050.
0.2236.
224. Okay, now you have to decide what quadrant is cosine in, and cosine needs to be positive. So it's instead of plus or minus, it's 0.224. So we found cosine. And now we have to find sine. Well, over here, we said that sine of theta is equal to cosine times cosine of theta, cosine of theta times negative 0.4366. So cosine is 0.224 times negative 0.366. And so what's sine? And it better be negative, right? Better be negative, and it is negative. So see, I'm always kind of checking myself. It is negative, and it should be negative. It's in quadrant 4. All right, so what is that? It's negative what?
0.0977984.
Yeah, it's about negative 0.7978. Okay, that is the lesson. I don't know. I think I wrote 1 through 19 in the book, but I'm gonna change it. I want you to do all the problems through 21. So you should be able to do them 1 through 21. So for those of you who want the lesson, and I'll try to change it today, it's page 858. Through 862, and I want you to do 1 through 21 all. All right. Anybody want to ask me any questions? I'm going to turn the recorder off. So if you're leaving and you have another class, have a great day. Have a good weekend. If you need to work on things this weekend, let me know. We don't have a test for a while, but don't wait till the last minute to study for the test and figure things out. Good luck with your AP tests, and I will talk to you soon. For those of you who want to ask me questions about this or something else, you can hang out. Let me just turn off the recorder.